I'm talking about WebAssembly beyond the browser. And a few of you said to me earlier, I remember you doing a talk on WebAssembly in London in the slightly murkier Sway bar last year. And yes, I did. I'm here to tell a little bit more of the story from where I left off. I was very careful to wear a different shirt this time. Now, if you saw my presentation last time, I made a few predictions. I talked about what was going to happen with WebAssembly in 2018, 2019, 2020 and beyond. I'm going to report back on some of the slightly more far-fetched predictions I made. Firstly, JavaScript's monopoly will be lost and its popularity will fade. Controversial. The other, the ubiquity of the web extends further still. That's the particular one I want to focus on now because I believe the ubiquity of the web is extending further and it's happening now. So some of you might not know what WebAssembly is. I'm going to very quickly give you an introduction to WebAssembly as a technology. And I find the best way to tell people about WebAssembly is to actually point to some of the deficiencies of JavaScript. Now, JavaScript development has come on a long way in the 25 years since it was first invented. These days, our tooling, our technology is really quite advanced. We have things like TypeScript, React. We do all kinds of clever transformations to our JavaScript code, yet this is how it arrives at the browser. The underlying delivery mechanism hasn't changed in 25 years. We do all this compilation, and what gets spat out and sent over to the browser is this garbled mess. And that's caused some people to consider JavaScript to be an assembly language. It's the runtime of the web. And that might seem okay, but actually it's far from okay. Because if you look at how this is actually executed in the browser, you'll find there's some significant challenges and problems here. Moving from left to right, most browsers have a similar kind of mechanism for loading and executing JavaScript. The characters are downloaded over HTTP. They're parsed into this thing called an abstract syntax tree that generates a bytecode which allows them to run within an interpreter. Now, 10, 15 years ago, JavaScript was an interpreted language, and anyone who's been around JavaScript for that many years knows that JavaScript used to be slow. These days, JavaScript's actually very, very fast, and it's because of the right-hand side of this diagram. What happens is the runtime watches the execution of your code, is able to make some optimizations, spit out some JIT-compiled code, and execute a lot faster. And this process is actually multi-tiered. It does all kinds of clever stuff, clever optimizations, and JavaScript's really, really fast these days. Eventually. And that's one of the big problems. It takes a long time to move from the initial load to the point where it's actually executing quite fast. Now, for WebAssembly, I'm going to skip all of the details. All I'm going to tell you is that WebAssembly solves some of the inherent issues around JavaScript delivery. So if we look at WebAssembly delivery in the browser, WebAssembly is a compilation target for a range of languages into a binary format. The binary format is sent over HTTP, and almost immediately it's compiled into very fast executable code. It's size and load time efficient. It supports streaming compilation. Your browser can actually compile WebAssembly as it downloads it over HTTP. It supports parallel compilation. It can split it over multiple threads and compile in tandem. It's designed as a compilation target. It's portable. It has a lot of fantastic features because it was designed for the way that we build applications for the web. Now, this is I think this is quite an interesting summary. This is a guy called Yehuda Katz. He was one of the developers behind Ember. And at the moment, most people are quite concerned about the amount of JavaScript code they send over the browser because they know their JavaScript is inherently costly. What Yehuda says is, JavaScript code is much more expensive byte for byte than an image because of the time spent parsing and compiling it. It's possible to parse and compile WASM as fast as it comes over the network, which makes it much more like an image than JavaScript code. It's a game changer. It really is changing the way that we potentially can deliver applications over the web. So what makes this possible? The thing that makes it possible is the WebAssembly virtual machine. So you're probably familiar with things like Silverlight, the plugin model. WebAssembly does have a separate runtime, but rather than being a plugin, which is quite distant from the existing virtual machine and runtime, WebAssembly is deeply embedded within the host, which in the case of the browser is JavaScript. Because it's for delivery over the web, security is at the forefront. It has a sandboxed approach. It actually lacks any I/O operations, so the attack surface is very, very small. If you want to perform I/O using WebAssembly, you have to go through the host. It's language and vendor independent. Again, sorry to pick on Silverlight, but history has shown that vendor technologies do not fare well within the web, whereas WebAssembly is a consortium effort. It's simple and it's fast. There are a lot of great properties of the WebAssembly virtual machine. And these are great properties for any virtual machine. It doesn't have to be a virtual machine running in the web, which is why over the past few years, a number of people, a number of companies have looked at it and said, yeah, we could take that virtual machine and deploy it elsewhere. And I'm going to tell you about a few of these use cases. The first is serverless. I'm sure you're all doing serverless these days because it's the cool new thing. Microservices are so boring. It's all serverless. If you've not come across serverless before, I'm sure you have, but I'm going to patronize you. This is the standard as a service model for cloud computing. On the left-hand side, this is on-premise. You start at the network layer, the storage layer, you layer up all of this boring infrastructure, and eventually you get to your data and your logic at the top. Infrastructure service throws away a small part of this stack. Platform as a service, again, moves a greater part of this stack over to your public cloud provider, and you just concentrate on your logic, your data, your application. Function as a service or serverless, I like to look at it from the other direction. The only thing that's left is your logic and your data. All you have to deal with is the stuff that you care about, and the cloud providers take care of the rest. Now, I'm going to let you into a little bit of a secret here. Serverless is a great big misnomer. Serverless functions, they run on servers. It's just that you don't find out about them. Well, unfortunately you do. If you've ever used serverless functions, you might have heard of a thing called a cold start time. Every time a serverless function is invoked, the cloud provider has to run up the whole stack. And if it's the first time a cloud function has been invoked, or if it's having to scale out and spin up new containers, the response time of your function can be seconds or tens of seconds. If you have a network of serverless functions, the response time can be minutes, which has caused people to do crazy things like keep their serverless functions warm, which is just a horrible architecture. So what can WebAssembly do about this? On the left-hand side, we look at the standard kind of virtual machine approach. For every cloud function, there's a significant process overhead, the virtual machine overhead. The little bit in the top left-hand corner is your code. Now, Cloudflare are a pretty well-known CDN network, and they're trying to move into cloud computing as well. What they did was they used the WebAssembly virtual machine as their isolation model. They have a very small process overhead and a much better mix of process overhead to user code. Using the isolation model of WebAssembly, they're actually able to run a great many more cloud functions on the same machine. Without going into the technical details, I like to compare the right-hand side to your browser. Within your browser, you have isolation. It's of critical importance that one browser tab cannot in some way invade another, yet you're able to switch from one tab to another incredibly quickly. It's the same kind of runtime model here. They're using that same property to allow them to switch between one serverless function and another. And this, of course, yields some significant benefits. This is the response time that Cloudflare measured on their serverless platform. I'm picking on Cloudflare because they've got some good blog posts about it, but Fastly are doing this as well, and other CDN networks and cloud providers will follow suit. This is their response time. Interestingly, if they did this chart for cold start times, the differences would be orders of magnitude. Cloudflare's serverless functions have a response time of a few hundred millimeters, cold or hot. Pretty impressive. So that's one application of WebAssembly out of the browser. The next one is as a completely standalone runtime. As I mentioned, WebAssembly has no built-in I/O functionality. There's a working group at the moment that's working on a specification called WASI, which is WebAssembly System Interface. They're trying to introduce a standardized set of system interfaces, I/O functions for WebAssembly, things like file system access, socket access. And it's a well-designed, pluggable interface. What this means is you can use WebAssembly entirely standalone, almost like a container or an operating system. Solomon Hykes, he was one of the founders of Docker. He said that if WASM and WASI existed in 2008, we wouldn't have needed to create Docker. That's how important it is. WebAssembly on the server is the future of computing, a standardized system interface that was the missing link. Let's hope WASI is up to the task. Another fascinating place that WebAssembly is moving to. There's not much web in some of these applications. The final one I'm going to talk to is the really cool one, blockchain and smart contracts. Everyone loves a bit of blockchain. Smart contracts, again, very brief introduction. Smart contracts are basically units of code. They're a bit like serverless functions. They're units of code that are deployed onto a blockchain network, and what that means is you can execute your smart contract amongst a distributed node of machines where you don't have any trust. They're immutable, they commit their results to the blockchain, that sort of thing. The leading provider of smart contracts on the blockchain is a company called Ethereum and the Ethereum network. And at the moment, they're working towards Ethereum version 2. There are a number of significant issues with the Ethereum network that they're addressing at the moment. They're moving from proof of work to proof of stake, which has a significantly lower computation cost. They're moving to a sharded network. In 2021, they're hoping to release EWASM. They're hoping to move away from their own virtual machine to one built on WebAssembly. And the reasons for doing that is they acknowledge the value of providing a platform where people can write smart contracts in a whole range of languages. At the moment, you have to write them in Solidity, which is a fairly new language, which, to be honest, most people aren't familiar with. And it's not just Ethereum who see WebAssembly as the future of smart contracts. Pretty much pick out any any smart contract startup, and I can pretty much guarantee that they'll be creating a WebAssembly virtual machine. It's becoming the de facto runtime. So, looking back on my predictions, JavaScript's monopoly will be lost. To be honest, I've not seen signs of that yet, but hey, it's not 2020 yet. The ubiquity of the web extends further still. I really think that's coming true. WebAssembly is pushing way beyond the browser, and it's bringing JavaScript with it. But it's not just bringing JavaScript, it's bringing Rust, it's bringing C#, it's bringing Go, it's bringing a great many languages with it. And I think as the Fin.js community, it's probably time that we acknowledge this. So I've got a big announcement. We're launching FinWasm. There's a website there. By all means, get your phones out and Mitra's glaring at me. Mitra's glaring at me. It's a joke, Mitra. No, or is it? It might be a joke. We'll see how many people sign up. So FinWasm. Interestingly, this website, you're all going on it now. Don't worry, I've deployed it to S3. It will scale. The actual sign-up process is written as a smart contract. It's written in JavaScript. You can actually sign up. I'm using the... not Perlin. I can't remember. I'm using the Near network. So yeah, the code's on GitHub as well. So if you want to sign up, you can create a wallet account, you can sign up, and everything's governed by a smart contract. And when I first put this together, I thought, yeah, that's a funny joke. And I thought, actually, it's not a bad application of smart contracts, because even though I developed the smart contract and I've developed the sign-up process, I can no longer game that process. If I wanted to give all the tickets out to my mates at Scott Logic, I can't do that. I can't change anything about it. So anyway, yeah, look forward to seeing you all at FinWasm at some point next year.